Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on radioactivity from March 2021 paper 2. And this paper is for Cambridge AS Physics 9702. For part A, it is given to us the results of alpha particle scattering experiment provide evidence for the structure of the atom. According to result 1, or simply you can say, according to first observation, the vast majority of alpha particles pass straight through the metal foil. In many books, they only mention gold foil, so it's the same thing, are deviated by small angles. Result 2, or the second result, according to this result, or according to this observation, a very small minority of alpha particles is scattered through angles greater than 90 degrees. From these results, we need to state what may be deduced from these results, means what we can deduce from result 1 and what we can deduce from second result. First of all, let's try to understand a little bit more about these observations. If you look at this figure, in this figure you can see this is source of alpha particles, and here we have detector, and here we have gold foil, means the metal foil. Now, if you look at this second figure, means if you look at only one atom. So this is representing only one atom. And you can see at the center of the atom is nucleus. And most of alpha particles, they just went straight through this atom. And this is our first observation. And this, according to second observation, if you look at this atom, you can simply see that from here, alpha particle is deflected back, and the angle it is deflected at an angle greater than 90 degrees, because this angle with horizontal is 90, and so this angle is greater than 90 degrees. And very few alpha particles, they scattered at an angle greater than 90 degrees. And this is our second observation, our second result. Now, according to first result, what we can say about structure of the atom? Simply we can say that, as you can see, most of alpha particles, they went straight. It simply means that most of an atom is empty space. So we can say most of an atom is empty space. So this is what we can conclude from this observation. This part has only 1 mark, and that is B1. So if you have written this mark, you will get 1 mark. Let's move on to second result. Now, question is asking us what we can conclude from the second result. According to second result, a very small minority of alpha particles scattered through angles greater than 90 degrees. So what this one is telling us, if you look at this one, first thing you need to understand why alpha particle is deflected back. Alpha particle has a positive charge, so this is the charge on alpha particle. This is positively charged, and the charge on alpha particle is equal to plus 2e. If this is deflected back, it means there is an other charge is present that is repelling this one backward. So it means the nucleus is charged. So first thing we can simply say that from here, nucleus is charged. It means there is positive charge in the nucleus. So nucleus is charged. So this is one point we can write down. The second thing we need to understand is that the mass of, from here we can also conclude that mass of an atom is concentrated in the nucleus, because most of alpha particle, they went straight through. It means nothing is in this empty space. So the mass of this one is concentrated in the nucleus. So simply we can say that mass is concentrated in small region, or we can say mass is concentrated in nucleus. Simply we can write down mass is concentrated in small region, and that small region actually is nucleus. We can also write down in nucleus. So if you write down these 2 points, you will get 2 marks, because this part has 2 marks. The first mark is if you have written nucleus is charged, you will get 1 mark. And the second mark, if you have written mass is concentrated in nucleus, you will get second mark. And these 2 marks are B marks, means it has to be in your answer. For part B, it is given to us a radioactive decay sequence contains 4 nuclei P, Q, R, and S. It is also given to us nucleus S is an isotope of nucleus P. First of all, let's try to understand what is isotope. Isotopes are atoms of the same element with same number of protons. Means isotopes, they have the same atomic number, or simply we can say they have the same number of protons. So this is first thing we need to understand. Isotopes, they have the same number of protons, or they have the same atomic number. But isotopes, they have different mass number. Different mass number simply means that they have different number of neutrons because they have the same number of protons. So the number of neutrons, they are different. And they're atoms of the same element because they have the same atomic number. So number of neutrons are different. So this is one thing we need to understand what is isotope. Now it is given to us nucleus S is an isotope of nucleus P. It means nucleus P and S, they have the same atomic number. So the atomic number of nucleus S is also 84. So this is atomic number of nucleus S. Now let's try to understand what is happening from P to Q. So when P decays to Q, you can see atomic number decreases by 2. So we can simply write down atomic number decreases by 2. And if we go from P to Q, the mass number decreases by 4. So it simply means this one is alpha decay. So we can write down this is alpha decay. Now if we look at the second one now, Q to R. So what is happening from Q to R? If you look at this one, atomic number increases by 1. But if you look at the mass number does not change. So simply we can say there is no change in mass number, but atomic number decreases by 1. So it is simply beta minus decay. So this one is beta minus decay. Now we need to understand what is happening from R to S. If we go from R to S, atomic number increases by 1. So we can simply say atomic number increases by 1. If atomic number increase by 1, so it simply means this is also beta minus decay. So this is beta minus decay because atomic number increases by 1. So in beta minus decay, mass number does not change. So it means the mass number will not change. So these are the basic things we need to understand what is happening. Now, if the mass number does not change, so the mass number of S is the same as mass number of R. So simply we can write down here the mass number for S. This is 214. Question is asking us the number of protons. Determine the proton number and the nucleon number of nucleus S. Nucleon number is the same as mass number. Now simply we can write down from here proton number of S is 84 and the mass number of S is 214. This question has 2 marks. If you write down 84, you will get 1 mark. And this is the answer mark. So simply you need to write down 84 to get this mark. And the second mark is also answer mark. If you simply write down 214, you will get second mark. For second part, it is given to us the quark composition of a nucleon in Q changes as Q decays to form R. We need to describe this change to the quark composition of the nucleon. First of all, let's try to understand what is nucleon. Maybe some of you are not clear what is nucleon. Nucleon simply is a particle in the nucleus. So simply we can say nucleon is a particle in the nucleus. So simply we can write down particle present in the nucleus. And examples of nucleons are protons because protons are present in the nucleus. And neutrons are also examples of nucleons. Now, if you look at this given nuclear decay means radioactive decay, we can see when Q decays to R, there is no change in the mass number. But if you look at atomic number is increasing by 1. If atomic number increase by 1, it means proton number increases. But the mass number is not changing. It means neutron number decreases. So simply from here we can write down, in this case, one neutron becomes proton because number of neutrons decreases by 1 and number of protons increases by 1. So this is the first thing we need to understand. Now question is asking us, we need to describe this change to the quark composition of the nucleon. So in this case, neutron changes to proton. We need to describe the change to the quark composition. Now, if you look at quark composition of neutron, it consists of one up quark and two down quark, and proton consists of two up quarks and one down quark. So from here simply we can say that one down quark changes to one up quark, and that's all what you need to write down. If simply you write down one down quark changes to one up quark, you will get 1 mark, and this is B mark, mean it has to be in your answer. So simply if you write down this much, you will get 1 mark.